We had, here's that weird Unicode stuff that we just looked at. Separate exploit to target. So basically it's just selecting like which shellcode do we want to use. So here we build out our shellcode. So our virtual address space is going to start at 400,000, like always in Windows. Build out our no ops. And then here's our driver function. Again, we see version checks. So we want to know which version has, which version we're on, so we know which exploit to use for targeting which vulnerability. One thing that's interesting is, this is all exploiting the same stuff. We saw the collabstore.collect email info exploit in the second PDF, but like they build it out differently in this one. So if you were always checking your PDFs for collabstore.collect email info, and like you were looking for that string, you wouldn't find it in this particular exploit. It still targets that object and it still gets the code to run, but it's just constructed differently. Just think of like the what's the C challenge where you're like you write like the nasty obfuscated C and it does something, but like it does it's hard to look at or hard to figure out. Like you're just kind of doing the same thing. You're just changing the way it looks, but you're actually getting to the same endpoint. Same thing here, targeting the get icon, except it's just referenced a different way. And then this is like our main chunk of code here, calling the driver function and then setting a timeout. So all in all, pretty easy. I'll skip working through the fourth one, but I just wanted to show you guys. This was the third one. The third and the fourth, like I said, the SSD, they had 85%, came back, said these two files are 85% similar. So when I started pulling apart the fourth one here, like it was like, oh yeah, like I see a bunch of the same stuff. So again, we've got another array, we've got our no-op sled function, got our launch exploit function. So it's like almost exactly the same stuff. It just turns out that this fourth PDF was just using different encoding, so it just looked a little bit different. So here's some interesting stuff. Okay, so this is object 26 and 27, right? Now check out this code. We got an object that sets a value of the same name as itself. Another variable, it sets itself to false. A function that does nothing. This part's interesting. Amet need will equals eval. So we've got almost like a function pointer basically. Some other random variables. And really, out of that, the only thing that we're really concerned about, the only thing that really matters in that is that eval. That's it. The other ones, they're just there as distractions. They don't do anything. This function doesn't do anything. This function returns true for no reason. It's just there as obfuscation. So we saw that assignment of eval. Here's a call to the amet need will. That was the variable that eval was assigned to. Here's a call to that variable. So what this is doing is calling the eval function on this variable, look manny dummy. So that's kind of interest. So we could look through the thing for look manny dummy. And I think what I actually did in cleaning it up is I removed that variable name. And I think I just named it something else. But I think initially all of this, all this code that we're scrolling through right now was all in one string that was assigned to the variable look need dummy. Or look many dummy. So it's just more ways of obfuscation. So that's it for the demo part of the JavaScript stuff, but I have one other thing I wanted to show you guys. Does anybody have any questions about the JavaScript stuff or any of the extraction from PDFs? Yes? You could, or you could disable JavaScript in your, if you use Adobe Reader or whatever. I know Document Viewer in Ubuntu, I don't think it runs JavaScript. And I mean, I guess like there's a reference available for the PDF standard. I think you have to pay to get the actual like ISO document, but I guess you could always, if you're feeling like open sourcey, you could always build your own as well. But there are alternative viewers, so. Well, in this case, the 4 files that we just looked at, they would all fail if JavaScript was turned on because they're using JavaScript to exploit the vulnerability. The vulnerability would still exist, but you don't have the delivery mechanism to exploit it if you've got JavaScript disabled. Sorry, in the back there.
Question. Pardon me if it sounds like a stupid question, but does the JavaScript interpreter, does it leverage like a browser's JavaScript interpreter, or is it Adobe Reader's JavaScript interpreter? And to what spec to what degree does it follow the MCA, whatever spec does it follow?
I don't know because I don't know, but I think that it is like one that's built by Reader. I mean, it mainly like the JavaScript we looked at all looked very normal. Like I didn't see any really funky stuff that was like, that doesn't look like JavaScript. So I think it is one built by Reader though, because I've seen complaints of people that make other readers and they're like, oh man, Adobe changed this. And so now we've got to go, update our code to like mirror Adobe's. And so like that makes me think that it's something that Adobe built and embedded. As far as its compliance with whoever wrote the standard on JavaScript, I don't know.
Okay, I have one more question. Dual core, when are you guys playing next? Any upcoming events that you're going to play at that we should know about?
We're playing tomorrow night at 9 o'clock. We're playing PenguinCon in Detroit, and we're playing FragFest in Traverse City, Michigan, and also in May. Yes, you had a question.
Yeah, it looks like there's a pretty good tool between, doing some manual work with Notepad++ and Didier Stevens' work. Is anyone trying to automate this to kind of like just grab streams, look at the filters ran, reverse that, and just kind of get you usable chunks that you can look at one by one without having to do so much legwork?
I haven't seen anybody publish online any efforts like that. But I do know one person who is working on something to help identify malicious PDF files. He's working with like avoiding false positives and avoiding false negatives, getting really accurate results to say, yes, this is an actually bad PDF file. Yes?
If you're looking into automation, look into the origami framework.
Okay.
It's Ruby stuff that takes apart PDFs for you, and it just tries to provide a library to do that.
Awesome. Thanks, Shardy. In the back. It's more for like a feature-rich offering from Adobe. So like, for example, one of the things you can do with the PDF is to build a form. Like you could build like an order form. And so you could assign like, dollar cost values to like products, and people might be able to fill out their order form. So you could say like, I want to buy 2 dual-core CDs and a dual-core T-shirt, and it would, the form using the JavaScript can calculate, okay, well, dual-core CDs are 2 for 15, and T-shirts are 15 bucks, so your total is 30 bucks. And then it can do that, but it can do that because of the JavaScript. And so businesses use it for that. Like that's a common purpose of it or common use. Right. Yeah. As far as I know, it does. Right. But we don't do PDF order forms. You can download you can pirate our stuff on BitTorrent. No, I'm just kidding. Seriously, you can. Any other questions on this stuff so far? Okay, cool. So I mentioned in the slides that there's a new research that's been being done where you can actually run an application without needing a vulnerability, without needing an exploit, without needing JavaScript, which is pretty cool. I'm not anywhere near the forefront of this, but I did code a PDF just for proof of concept. So this is our PDF. We're just going to open it and fox it. And so it does come up with a warning and says you're about to run this file, C Windows System 32 command.exe. And you open it, and then just for a demo, I just have it ping localhost. Nothing major. But what you can do, the way that this works is that the back half of it is like shell execute, if anybody's done any Win32 API stuff. So you can pass in like different arguments and stuff like that, so you can chain things. Some of the cooler stuff that I've seen Didier Stevens do and this other guy, Riot, Didier Stevens can tamper with that warning message that popped up. And so instead of it saying like, hey, you're about to open this file, see Windows, cmd.exe, he can make it say like, hey, here's that encrypted PDF document that I sent you. Just click the checkbox, don't show again, and then click open to decrypt the PDF and view the contents. And then his PDF will say, encrypted document or whatever at the top. So there's definitely a social engineering aspect that's employed. But I mean, if you're expecting a document from somebody, or you just, you get a PDF document, like everybody raise their hands that somebody above them in their org chart is fine opening a PDF document, they're definitely going to open that. And that's going to run, whatever app on the system that is built into the thing. And there's no warning that that's what's actually going on. One of the things I've seen Riots do is he's got a proof of concept in Foxit where he can open a reader or open up the PDF. It doesn't show the warning, and it just runs a program. It drops another program and changes the background color. There's a video of it up on YouTube. I think his YouTube is Riot Security or something like that with a Z. But there's a lot of research going on right now, and this is all like very new stuff. Like I had made the talk initially, and I was just like, yeah, JavaScript exploits. But this stuff's pretty new, and it's kind of cool. Also scary, I guess, if you're worried about it, but it's kind of neat stuff. Oh yeah, sorry, we should probably finish out the talk. So here are the references. By all means, please do check out Didier Stevens. I don't think I can shout him out enough. He's a real smart dude, publishes a bunch of stuff. He's got a lot of other research outside of PDF stuff. So a lot of cool stuff. Check out the Malzilla app if you have a Windows VM or Windows install. It's really nice, got a lot of features, really helpful for doing PDF stuff. And then if you're interested, or you're just an insomniac and you can't go to sleep, check out this PDF reference. It's about as dry as you can get, but it's got like most of the core workings in there. Any other questions or anything? Yes.
Would running through PDF filter Google Reader
I would think so. I guess I haven't tried, but I would think that Google's document viewer probably doesn't run the JavaScript, and send it out to your browser to run. And even if it did, then you have to have you have to craft your JavaScript to attack the browser at that point, or to do stuff not, considering it's running in Adobe Reader. Because what we looked at, they've got heap sprays. They're trying to spray stuff into memory. I don't think the browser's going to really fly with that. Or the exploit won't fire. It'll be referencing an object that isn't there. Yes. Right. So if you've ever written like a memory corruption exploit before, like a Stack Overflow, you're using C to or Python or whatever, Ruby. You're using that to load your stuff into memory and overwrite certain registers and values, and then jump to where your code's going to execute. This is doing that exact same thing, except it's in JavaScript instead of Python or Ruby or C. Right, just to launch an application, and that is, yeah, yep. So if you've got like a dropper that already drops, and you know that it's going to have downloaded some other file, you could run that file through the PDF if you wanted. But yeah, and that's built into the standard, so it's cool because it doesn't require a vulnerability or an exploit. Yes.
So as you were doing this research, did you uncover anything from Apache? Or I'm sorry, from Adobe that indicates that they're starting to take this seriously and are going to start doing stuff to protect us? Because it just seems like, work that you're talking about and what DDA is doing, it just gets scarier and scarier.
Yeah, Adobe's kind of like the new whipping child right now. Their response hasn't been phenomenal, to be nice about it. Like I said, I saw this stuff come through work in 2008, and I mean, this stuff's still getting exploited. I don't know. I think they're trying to some degree, but if you look at the stats of like the number of attacks that have been going on, and like I've seen graphs where it's like like X percentage attacked Flash and X percentage of attacks attacked PDF reader, it's a pretty high percentage. I mean, like attackers are really focusing on this stuff. And so Adobe, I would expect a more significant response from Adobe. Yes, Ryan.
How are the antivirus vendors responding to this, if at all? Like Symantec, Trend, Kaspersky, are they even, is this on their radar at all, or no?
I don't know, to be honest. I don't really have any contacts with them. Shardy, disclose your disclosures. I don't believe Shardy. He's Canadian. I'm just kidding. Shardy's awesome. Was there a question over there? Oh, okay. Cool. Any other questions? Cool. Thank you, guys. My name's int80. I'm the rapper in dual core.